My name is Eliud Polanco, and I'm the president at Fluree. Today, we're going to be talking about the subject of model, map, and connect, which is a framework for how to create rich semantic data. Let's go in and let's take a look at model, map, and connect in action. The very first step is to model. And in this case, Fluree has the Intelligent Taxonomy Manager software, which allows teams to collaboratively define their classes, properties, the constraints within the properties and classes, and the relationships across and between them. Here is the Intelligent Taxonomy Management software. As you can see here, the interface allows you to manage one or more taxonomies or ontologies across your organization. And across these different taxonomies, you'll have various different classes, and then you may have even instances of those classes. So let's look at a specific graph-based view. In this case, we're going to look at the class called person. And in this case, from the graph, we'll be able to see that a person has certain properties. And so we can define what are the properties, the object properties of this class called person. But then also see that a person has a relationship via an employment role to an organization. And then a person may have a skill, and a skill is a different class, and then this class has its own properties. And so this is just a visual way of navigating a business ontology or a model. What's really critical is that not only can we go in and define the model, but we can then manage the information itself within the model. So let's say in this case, we've defined a person, and we said that a person is a type of agent, and we're going to give a unique ID to that specific concept or this class called a person. And then a person will have different properties. So a person has a name, it has an identifier, it has a skill, and it could be an expert in something. And then we have associations. And in here, we can say that a person has an employment relationship with an organization. And then if we can go in, we can actually go into more details and say, now when we go in and we said that a person has a skill, we can define a unique ID for the class of a skill, and then have a unique ID for each instance of a skill. So in this case, we're saying that active listening is a skill, and this active listening skill has its own unique ID. Now, critically, as we start mapping the data, what the system is going to do is the system is going to discover potential new candidates. And candidates are new potential concepts or instances of classes that the system has discovered by analyzing and scanning data. And this is typically what's done through the second step, which is our map step. In our map step, we have two different applications. There's one application which focuses on mapping structured data and one for unstructured data. For structured data, we're going to take a look at our Fluree Sense application. And what Fluree Sense allows you to do is it allows you to overlay or map one or more different ontologies to structured data tables, basically database tables are things that we would expect to see in a spreadsheet. And we can also go one level deeper and enrich and classify at the record level, as well as link and connect different types of information from across multiple databases to the same type of class or entity. This is the Fluree Sense interface. And within the Fluree Sense interface, here we will have brought in several different ontologies or models. And from here, users can take the models which could have been imported from the Intelligent Taxonomy Manager or any other modeling tool. And then we kind of go ahead and take a little bit of a deeper dive and take a look at it and say, here we've got different classes. And then within each of the classes, we have the properties that represent the classes. So this is just a tabular view of the same model information that we looked at within ITM. And the goal is going to be to take data. So in this case, we've mapped data from many different data sources, including our ERP system, our financial reporting system, our product marketing database. So we've brought in data from lots of different sources. But ultimately, what we want to be able to do is we want to be able to take information that is structured, meaning it's in this tabular format, and we want to be able to overlay the various different ontologies or business models onto the data very quickly. And so ultimately, one of the goals will be to automatically have the system start generating these visual graphs. And so this is a graph that is displaying the relationship that says this specific table could be described in one or more ontologies. In this ontology, the IDMP, you could use the substance identification class and map various database columns to various different properties within this class. Or we could use this ontology, the Gen Pharma Catalog. And in this Gen Pharma Catalog, there are properties of the data that could be linked to a pharmaceutical product class, or a substance class, or medicinal product. And again, we can also connect the information to this GSRS ontology, where we describe substances and structures. Now, the way that this is generated is through the AI or machine learning, where we're going through individual columns. And so we'll take this specific column. And for each column, we'll define, by using its data profile, we'll study the metadata and the data and generate a unique feature vector or a signature for this column. And once we have these feature vectors, we can then start to train the machine learning models to go through and identify what are the possible different concepts that map or correlate to that feature vector. And then we can have different subject matter experts across the company agree or disagree. And then we can keep a rolling tally or tab of who voted to say that they agreed that this specific column is correlated to that specific concept. So this is an example of being able to do that first level classification, which is to be able to take database tables and map database tables to potential classes, as well as map individual columns to corresponding potential concepts. Now, one level deeper than being able to tag the table and the column is to go to each individual record itself and then add additional classifiers or impute additional information based on being able to study the contents of each record. In this case, what we're going to do is we basically have, as part of our ontology, the ability to define a substance type and say, if I know that something is a substance, then I could tag that record to one of these 7 unique different types of substances. And in this case, we have identified that we have a concept called a substance type, and we want to be able to study and introspect the contents of a record and determine whether that record is a chemical, or if it's a protein, or a mixture. So in order to do that, what we're going to do is we're going to create a classification project. In that classification project, we're going to try to tag a record to the IDMP substance type. And in this case, we've generated a very quick machine learning model that's at a current level of confidence. You can see the confidence level here. And the goal is ultimately to teach the model to get to a level where it's about 80 to 90% confident that it knows how to scan, read the contents of the record, and be able to come up with the appropriate classification. Let's actually take a look at the results. And we actually have the results here. And so when we look at the results, in essence, for each record, the machine is going to try to read the contents and then try to make a prediction what is the appropriate IDMP substance type that we can classify or tag to this record. So the system in this case is 100% confident that this specific substance is a protein. But it's less confident on what to do with this specific record. Or if we take a look at this record, this could either be considered a chemical or this could be a nucleic acid. The idea here is that a subject matter expert would go in and say, look, it's either a chemical or a nucleic acid, and I can give thumbs up to one. Or I could give thumbs down, and if we give thumbs down, then we can give additional information and say, well, if it's neither one of these, then what else could it be? And ultimately, by doing this, we're going to teach the machine to get smarter. And a structured way to do this is to go through a formal training process, where in a training process, the system will automatically generate a series of tasks. And then these tasks could be assigned to different subject matter experts in the company. And then the subject matter experts will be able to go in and they'll be able to go through and start making specific recommendations. So let's say in this case, we have this specific substance. We don't know what it is. We know it's neither polymer nor structurally diverse. So what we could do is we could either pick an option, or what we could do is we could say, if none of the options are here really describe what this is, we can add a brand new class name. So let's create this and call this new substance type. And we'll add this as an option. And now what we've done is we've now created a brand new candidate term. And this candidate term is something that would then appear back on our ontology manager so that we can go back and say, look, do we want to include and formally ratify the introduction of that brand new classifier into our ontology? So let's finish this task. Great. So as we go through this process, ultimately the goal will be that once we've enriched the data with all the necessary information, we'll then be able to click on this button, export the data as a graph, and now we've converted all of this tabular information into this rich semantic form. And in a couple minutes, we'll take a look at what that actually looks like once we finish the conversion. So this is an example of kind of going through the mapping for structured data. We can also do something similar for unstructured data. And in unstructured data, what we're looking to is we're looking to take in documents. These could be PDF documents. These could be audio files, video files. But we want to run through a similar process, which is, can we actually scan the contents of the unstructured information? And can we do a similar process, link it, and connect it to our ontological terms? Let's do a quick demo and take a look at what that looks like. In this scenario, we're going to take a look at a health ontology. And what we're going to do here is we're just going to pick from a couple of different articles that have been preset. And so we have this specific set of text. And what we're going to do is we're just going to run our content auto tagging manager. And so what this is going to do is it's going to start to describe what are the key classes from an ontology that were present in the information. And then we can see here how it's describing the information based on relevance and frequency. And so if we take a look here, we can see how it's individually tagged specific terms to various different concepts within our ontology. Again, as we discussed, each of these different ontologies, each of these different terms has a unique IRI. And that's how we'll be able to start tagging the IRIs back to the individual documents. In addition to describing specific terms of the ontology, it can also identify new candidates. So in this case, it's going to recommend that we have this new term. And this new term should be added as a candidate because this wasn't in our ontology before. And then we can have our experts go through, validate, and choose to agree or disagree whether to add this to the ontology. And if we do, then we would generate a unique IRI for that specific term itself. So this is an example of how we're also running through a mapping process for unstructured data. But again, this has a series of machine learning algorithms that are running under the covers. Now, once we've done this mapping activity, we can now take this information and bring it into our knowledge graph. And in this case, we're going to load the data into Fluree Core, which is our knowledge graph application. So this is our Fluree Core interface, and this is our cloud-based version. We have versions that run on-prem as well as on the cloud. And so if we come here, we'll be able to take a look at a series of different data sets that I have access to from within my login or my credentials. And we're going to take a look at our GSRS data. So this is the same substance data that we previously had inside our database table, but now it's been loaded into the graph. Now let's take a look at some of the interesting and unique properties and things that we can do with the information once it's in the graph. So first things first is I'm just going to pull up this notebook. And this notebook is going to walk us through a little bit of the behind-the-scenes process for how easily we converted the structured data that we had in our database tables and how we brought it into the graph and what were some of the benefits of bringing it into the graph. So first thing is we're going to first load and bring into our graph database the actual ontology or the vocabulary file. In this case, what we're seeing here is we have a specific ontology called GSRS. It was describing a thing called the substance. And then we have here the names of the properties and the descriptions of it. So we're going to bring all the business metadata, all of our ontology information, our classes and properties, and the IRIs, we're going to take it, we're going to import it, and we're going to transact this, or basically import this into our graph database. The second step is then we're going to take the data itself, and we're also going to bring the data and transact it into the knowledge graph. Now, our knowledge graph database is using a document format called JSON LD. And in Fluree Sense, when we clicked on the button to export the graph, it automatically created this JSON LD document for the data that was introspecting. So in this case, we're looking at the GSRS substance data, and you can see here how we're basically instructing it to insert these JSON objects into our database. And so we'll just go ahead, and under the covers, we've now inserted this specific set of information into our knowledge graph. Now, once the data is inside our knowledge graph, we can now generate Sparkle, or in this case, we're going to look at Fluree QL, but we can generate queries to look for and ask for information. In this case, we're looking for, this is the equivalent of kind of a select star query in a SQL database. We're just looking for any instance of a substance that has a UUID. And the system has come back and it's generated the set of JSON objects that we loaded in the beginning. Now what we can do is we can actually load another ontology or a second vocabulary and bring this into our graph. So when we were looking at the information from the Fluree Sense screen, we saw that the same database table could be described using multiple vocabularies or multiple ontologies. So what we're going to do is we're going to load one of the other ontologies, in this case, the identification of medicinal products ontology, and we're going to load and bring this one into the graph. So same thing, we're going to bring in the descriptive, the business metadata, the contextual information, and we're going to transact and bring this into our knowledge graph. Now, one of the other things that happened through the machine learning mapping process is that the system discovered automatically relationships between and across multiple ontologies. So, for example, what GSRS, this property called approval ID, from this substance in this ontology, is actually equivalent to a substance code from IDMP. Or what GSRS calls a UUID is what IDMP calls the moiety identifier. And we're seeing how we're using this equivalent property here to describe in systematic fashion how we can use either term to relate to the same type of data, even though they have different names. And the reason why this is valuable is that we can now go to the final cell here, and we can actually query the same information that we previously loaded. But instead of using the GSRS vocabulary, now we can change the vocabulary and query the same data but using a different vocabulary. Now I can query the data by saying, get me any substance that has a moiety identifier. And if I query the data set, I will now get back my response that, again, it's another way of retrieving the information. But now I can query the data using a vocabulary that I'm more comfortable with. And again, that's one of the benefits of the values of being able to bring the data into the graph. So hopefully this gives you kind of a quick overview of how we use the suite of Fluree technology to be able to build your model, map structured and unstructured data into the model, which converts the data into JSON LD or RDF. And then we can bring the JSON LD into our Fluree core database to be able to transact it. And we can also set policies and provide governance and control so that we can share the information safely with other members of the team.